I apologize for not being able to fit all of this information in the previous video, but this is just a few minutes to wrap up Rocks 7.4. So I left you off with this picture, and what I'm showing here is Mammoth Mountain, and actually in red are the ski lifts, if you've been there, and then in blue is the river system of the mountain. I've shown in black the edge of the Long Valley Caldera to show you how the Mammoth Mountain area really is within the caldera. So notice this town right here of Mammoth Lakes. In May of 1980, only 1 week after the incredible eruption of Mount St. Helens, Mammoth Lakes experienced a magnitude 6.0 earthquake. The earthquake occurred about 10 kilometers to the southeast of Mammoth Lakes. During the next 16 minutes, 4 magnitude 4.1 to 5 shocks and 1 5.5 shock occurred. This seismic activity was the beginning of an earthquake sequence that produced 72 magnitude 4 to 4.9 events, 6 magnitude 5 to 5.5 events, and 3 magnitude 6 to 6.3 earthquake events in the next 48 hours. Thousands of earthquakes of magnitude less than 3.9 were generated during the same time period, a 48-hour time period. The general interpretation was that all of these earthquakes indicated magma moving below the Long Valley caldera and rising towards the surface. These earthquakes were also associated with 10 inches of uplift in the caldera floor. And there were also changes in local thermal springs and gas emissions as well. In the years following this series of earthquakes, scientists from the U.S. Geologic Survey discovered that trees were being killed by high concentrations of carbon dioxide in the soil. And the seepage of this gas from below Mammoth Mountain continues as a sign that there is some magmatic unrest. The areas of dead and dying trees around Mammoth Mountain total more than 100 acres. The figure right here is showing a region called Horseshoe Lake, which is just a bit south of the map I have here. And it's showing the carbon dioxide flow measured out of the ground in grams per day per meter squared. And basically, the farther you go up on the color chart, the more carbon dioxide is coming out of the ground. And normal levels are around 25, 0 to 25. And so that's kind of the white area. And so you can see that the amount of carbon dioxide coming out went way up, over 7,000. And here's a picture of those trees that were killed from this intense amount of carbon dioxide. They just couldn't handle it. It was like poison. Here are some other pictures. This is showing the Long Valley caldera, which you've seen a couple times now with Mammoth Mountain on the side. This is a blow up of Mammoth Mountain, and in yellow are areas of tree kills. Here's Horseshoe Lake that I was just talking about, and in yellow areas where the trees have been killed. And then this is a view looking towards that Horseshoe Lake. Doesn't look like a horseshoe to me, but anyway, that's what they call it. And then there's Mammoth Mountain over there. In addition to the earthquake activity and the uplift in the caldera, there was also a ground fracture, a fault, that exhibited about 10 centimeters of displacement east side down, which goes with the normal faulting along this area. So the story is that when these initial earthquakes occurred, a reporter from the LA Times heard about this, and he ran a story in the LA Times talking about the fact that Mammoth Lakes and this region was about to explode in a violent and incredibly enormous eruption. Well, Mammoth Lakes and Mammoth Mountain pretty much depend on tourism for their livelihood. And so this was a real big disaster, and there was a big argument between the reporters and the geologists, and there was a whole series of events that occurred to try to calm the people of the town and also tourists who buy houses and second homes, etc. in this area. I'm going to jump back here to this slide. One thing that the townspeople did was they realized that the only road into Mammoth Lakes and Mammoth Mountains was this one road shown here. That this is Highway 395 here, and it was the one road that connected 395. So they said to themselves, well, if there's some sort of volcanic eruption and this road gets blocked, we're in trouble. So they built this second road, which is shown here, and it was originally called the Mammoth Escape Route. and the businesses, etc., of the town did not like that. So now it's called the Mammoth Scenic Loop. And if you go up there, sure enough, that road is called the Mammoth Scenic Loop. And really what it is an escape route. Since this time, Mammoth Lakes has done fine. Tourists are back. Everybody's happy again. This was back in 1980. You know, time heals all memory of disasters, I guess. Okay, so we looked at 3 volcanoes in Northern California related to subduction. We've just looked at Long Valley Caldera related to extension. Remember, the basin and range out here is extending, and that rifting or extension allows magma to reach the surface. The rest of the volcanoes here are primarily related to extension in the basin and range. Salton Buttes and Clear Lake Volcanic Field are related to something a little bit different, which is called a stepover in the San Andreas Fault. So here's a little cartoon showing the San Andreas Fault, right lateral strike slip fault, a transform boundary. And if there happens to be a bend in the fault, which there often are bends in different parts of the fault, what's going to happen with time? Well, if the bend goes in this particular direction, the real estate on the right is going to move down to the right. The region to the left is going to move up and to the left. And what's going to happen is it's going to create this hole in between. And that's exactly what the Salton Sea is. It's a big sea inside this hole of a stepover from the San Andreas Fault. And that's also what happened up here in Clear Lake to contribute to volcanic activity. So when you make a hole in the crust, magma has the opportunity to decompress, melt, and rise. Finally, I decided to finish by showing you what a nerd I am. I have a piece of the Bishop Tuff and obsidian from the Obsidian Dome in my yard because I have rocks in my yard because I'm a geologist. And I threw in a playing card there for scale because geologists like to have something for scale. So here's the Bishop Tuff. It's a rhyolite. You can see some pumices that are those are the lighter colored things. When the volcano erupts, these are parts that are filled with gas. And so once they cool, you get an object called pumice, which is primarily glass filled with lots of holes. And so this is my chunk of the Bishop Tuff. And then obsidian is volcanic glass. And here you can see a close-up of the obsidian. You can clearly see a flow structure in this direction. The dark color is the glass and the light color is glass sort of breaking down. This glass is not very stable at the surface. Make sure you check out California's active volcanoes when you get a chance. They're pretty cool to hike around on and think about how recent volcanic activity occurred in California.